Hi, my name is George Garcia, and I am a Community Manager with Fusion 360 Electronics and Eagle. Welcome to Episode 3 of our A to Z project series. Now, at the end of our last episode, we finished the schematic, which you can see, this is where we left off. And in this episode, we want to cover defining our board outline. So we're not going to go into the layout just yet, but rather we're going to analyze the various ways that we can define our board outline. There are namely 4 different ways that we can define our board outline. We can draw it manually, we can import it as a non-associated PCB, we can import it as an associated PCB, or we can generate the 3D PCB from the board and then use edit and place workflows to define our board outline. So in this video, we're going to go through each of those 4 steps. So let's start with the first option, which is the easiest and the most straightforward, is we're going to go into the board. Now you can see that we have a default board outline. Now this board outline is generated regardless of what you do on the schematic. When you generate the board from the schematic, you're going to see this board outline. And it's basic, it's just a rectangle, and we can turn it into whatever board outline we need. Now you'll also notice that all of the components and the connections we define in the schematic appear here on the bottom left side in the negative X and Y axes. This is how backward and forward annotation works in Fusion Electronics. Anything you do on the schematic, any components you add, will appear in the negative X and Y axes on the 2D PCB, and any connections you define will appear as these thin air wires. Now, if we look at the board outline, you're going to notice that the inside of the outline is black, whereas outside of the outline, we have gray. Whenever you see this color difference, this is letting you know that Fusion 360 Electronics has properly detected the board outline. And this is vital in order to be able to create a 3D PCB. So if while you're working you don't see this color difference, know that your board outline is not properly configured. Basically, all you need to have a proper board outline is a closed continuous contour. And all that has to be is drawn on layer 20 dimensions. And that's what you can see here. So if I click on any of these segments, you're going to see in the inspector, it's on layer 20 dimension. That's the key requirement. Whatever outline you make has to be a closed contour on layer 20. Now, the first option we had for defining our board outline is simply editing it here on the 2D PCB. So I can go ahead and I'm going to move these segments to shrink them. You'll see the outline updates. Let me go ahead and zoom in a little bit more. I can use something like the miter tool. Just add a big miter right here. Make a rounded one over here, etc. This is the first way that we can define our board outline. Very simple. Very straightforward. Just draw it. And I could even delete this whole outline and just redraw a continuous contour on layer 20 using the drawing tools under the document menu. So this is option number 1. Now we're going to go into option 2. Now option 1 relied simply on drawing the board outline in the 2D PCB editor. But options 2 through 4 all rely on having an enclosure and defining the board outline based on that. So that's what we're going to do now, which is a much more realistic scenario. More often than not, you already have an enclosure that you want this PCB to go into. So let's go ahead and explore that. So I'm going to go into the design panel over here, and I have an enclosure. You can use any enclosure you want. Let's go ahead and open this file. And you're going to notice that options 2 and 3 are very similar. They actually only differ in one main step. So we're going to kind of deal with them together. So here you can see the enclosure. Now this enclosure is a step model that I obtained from the manufacturer. And the first thing that should tip you off that you need to do something special is the fact that there is no timeline at the bottom of the screen. Okay? We want to be able to capture the design history. So the first thing you should do whenever you open a step model that you've obtained from a third party and you notice that you do not have a timeline at the bottom is go ahead and right click on the main component And at the bottom of the menu, you're going to see Capture Design History. This will now enable a timeline, and it will keep track of any changes you make to the model. So first thing I'm going to do is I'm going to take off the lid. I'm going to hold Shift so I can orbit the box. Okay. And what we're going to do for workflows 2 and 3 is we need a sketch to define what we want the board geometry to be. So I'm going to go ahead, use a construction plane. I'm going to base it on the bottom here of the enclosure. I'm going to go ahead and just raise it off the top, maybe 3 millimeters. Okay. Now we're going to go ahead and make a new sketch. Make a sketch. I'm going to use that plane. And the first thing I'm going to do is I'm going to project the features of the inside of the enclosure. That way I can base my board outline on that. So let's go ahead and I'm going to go ahead and project. Now we're going to select the profile that we want to project. I want to project this overall profile. I'll say OK. And we get all this data. Now I don't need any of this part of the model here, so I can just delete that projection. And it looks like it selects the whole thing, but it doesn't. It just selects those pieces. Okay. The next thing I'm going to do is I want to offset, because if I put a board in this enclosure, I don't want it to be right up against the edge. We need to have a little bit of tolerance. So for that, I'm going to use the offset command. And I'm going to just select this outline. And you'll notice that it wants to go beyond. I want it to offset in. I want it to cut into. So all you have to do is use negative numbers. So I'll put negative, let's say 2 millimeters. Okay, so now we know this board is going to be smaller than the enclosure, and it should fit, giving us a little bit of tolerance. So I'm going to hit enter and have that. Next, I'm going to go ahead and use the line command, and I just want to draw from the midpoint here to the midpoint here. Okay, and I'm going to go ahead and finish the sketch here. What this is going to allow me to do is I can use either side as the basis for the PCB. So now what we're going to do is we're going to go create and create PCB. Now this is the one step where options 2 and 3 differ. For option 2, we're going to pick create independent PCB. For option 3, we're going to create associative PCB. What's the difference? Well, let's start by creating an independent PCB. Okay, it's going to ask me to select a profile. I want to use this profile. Okay, notice that it's defined the center or the origin of the board to be that midpoint. I don't want it to be there. So I'm going to select origin here, and I do want to pick it. I want this bottom left corner here to be the origin. So I will select that. Now, we know that the x-axis is the red line, the red arrow. This one is also not the way I want it, so I'm going to click select, and I can pick an edge of the board. Okay, I'm going to pick this edge. This is what I want to be my x-axis. So I selected it. Now notice that it's pointing 180 degrees away from what I actually want to be the x-axis in the electronics environment. So I'm going to select flip x-axis. Now it's perfect. So at this point, I'm going to say OK. Now you're going to notice that this PCB is completely independent from the model we originally created. So if you look over here, here's the model, here's the PCB. Now, when we say create an independent PCB, what we're doing is we're taking a snapshot of the sketch. It is not linked in any way to the original sketch. So the original sketch can change, can be deleted, you can do anything to it. And this PCB will not change in any way. It is independent. So the disadvantage is that if you make any changes to the sketch because the enclosure changes in some way or needs to be modified in some way, this PCB will not update. It does have one advantage though, and that is that it can be reinserted into the original model. So we're going to see that in a second. I'm going to go ahead and save this. Let's go ahead. We want to save this 3D PCB, and I'm going to call it independent PCB. Okay, I'm going to click Save. Now, how do we associate it to our 2D PCB? Very simple. I'm going to click over here. This is our link to 2D PCB command. I'm going to select it. I'm going to select which PCB to link it to. The one in this project. I can link it to anything else in my hub. I'll say select. And as you can see, we have the outline here in the 2D PCB. Now notice that it says the 2D and the 3D PCB documents are out of sync. Why does it say that? It says that because the 2D PCB has components. The 3D PCB does not. So at this point, to put them into sync, I'm going to hit push. Now you'll see we have these options. These options are useful if you want to speed up the pushing process. You can also verify what components are going to be pushed and if they have 3D models or not. So I'm going to say OK. And obviously everything is going to be off the board. And as you can see, we have the PCB and all of the components are here, but they are off the board. Now one thing that is important to note, the 3D PCB file, this one that I've named independent PCB, should only contain PCB information. You do not want to add anything into this file. You don't want to add any external assemblies, any additional 3D models. You don't want to do any of that. The reason is the 2D PCB won't have a one-to-one representation for it. So it'll make it difficult to keep them both in sync. So if you want to have an enclosure, if you want to put the PCB into an enclosure, you do that by adding it as an independent assembly to the enclosure, but not here. So just remember in your mind, the PCB file, the 3D PCB file, can only contain PCB related elements. So at this point, let's go ahead and save our main design. Okay, I'm going to say I added independent PCB. And what you're going to notice is once there is a 3D model associated with the 2D PCB, so a 3D PCB associated with a 2D PCB, it will show up here in the electronics design file preview. And if we expand this tree, we'll see that it's here as well. Okay? Now, remember how I said there is an advantage here. And the advantage is that we can add this independent PCB into this 3D model. So I'm going to go ahead and save it. Always write a description. Always. It'll give you a paper trail of all the changes you've made. And especially if you're working in a team, it'll help you keep track of who did what. I'm going to say OK. All right. So now that we have it saved, we can add this independent PCB back into the original model. So we can see what it will look like in the enclosure. We can do test fits. We can check all of that. That's the advantage that making the independent PCB has. So again, like I mentioned, if you do independent PCB, you're taking a snapshot of the sketch. It has no, once it's made, it has no connection back to the original sketch. You can update the sketch, you can delete it, you can destroy it, you can do anything you want with it. The independent PCB will not update. Its one or main advantage is the fact that you can go right-click, insert into current drawing, and then you can rotate it and orient it the way you want it to be. Okay, and then we can do a point-to-point. Select here, select this bottom part there. You know, we can see that it fits and start doing checks for it. Okay, so that's its main advantage. Now, I'm going to go ahead and remove it because we're going to now go through option 3. I'm going to cancel the move. I'm going to delete this. Now, let's go ahead and make a associative PCB. So, works exactly the same. So we use the exact same sketch we made. We do everything the same. I'm going to go create. create PCB, we're going to create an associative PCB. Okay, have to save. Let's go ahead and save first. Added, then removed independent PCB. Fusion keeps track of every time you make a change, so it considers it a dirty file, even if in the end you don't have anything new. So again, we select our profile. We're going to select the origin. We're going to select the x-axis. Pointing the wrong way, so we flip it. All right, and we say OK. And now we have this 3D PCB here. I'm going to go ahead and save it. It's not associated yet to the design. I'm going to go ahead and save it. I'm going to call this one Associative PCB. Hit save. Okay. Now we have this associative PCB, and the big difference between associative and independent is this is still linked to this sketch. Any changes to this profile will be reflected here. And that's its strongest benefit, is the fact that changes in the sketch will track to here. So let's go ahead and make a change to the sketch. I'm going to right click, edit sketch. I'm just going to add a hole, add a circle over here. Okay. Go over here, say finish sketch. Okay, I've added the hole. Now let's go ahead and save it. Added a hole to the PCB outline. Say OK. All right, it's saved. If we go to associative now, you see how it detects that the sketch changed, and it now wants me to pull these changes in. So I'm going to select it. You're going to see that it looks like nothing happened. But if we go here to edit board, you're going to see that there's a sketch. So the profile, in order to update it, all we do is we remove this element. We say OK, and now it's updated. So again, now I'm going to save it. Say added hole. Okay. Now, again, I still haven't linked it. I'm not going to link it yet. What I want to show you is the downside of the associative PCB. Okay. Its downside is if we go back to the original model and we want to insert it to check its fit, look what happens. I'm going to right click, select insert into current design. What you'll see is you get an error. Cannot insert associative PCB 2 into the enclosure because it will create a circular reference. So basically, because we've derived it from this sketch and it's linked to the sketch, if we insert it here, it's basically going to link into itself. And that isn't allowed, because then the file will break and it'll create all sorts of problems. So this is its biggest weakness. Now, it can be worked around, and I'm going to show you that now. New design. All you end up doing is you save this. I'm going to call it combined file. Okay. And what you do is you go ahead, you take the enclosure, you insert it. Okay. You say OK. And then you take the associative PCB and you insert it as well. This is the workaround. Okay, basically what you're doing is you're indirectly working around the circular reference by using this intermediate assembly file. Okay, and then I can do point to point. There we go. Okay. So this is the workaround. If you want to maintain that link, this is how you do it. So what I'm going to do now is I'm going to go ahead and close this file. I'll save it. Just say showed issue with Associative PCB. Okay. In some occasions, you may not want to create this third file to be able to have them keep track. Okay. So now what we're going to do is, if we want to link it, we want to link the Associative PCB to our 2D PCB. First thing we have to do is we go here to Switch, and you say Remove 3D PCB Link. Okay. Once you do that, you're going to save. Again, I'm going to do it from here because I want it to waterfall. I'm going to say Save. Broke link to independent PCB. Okay. You'll see, link is gone. Now we go to our Associative PCB. I say link, select A to Z. I can select. Okay, and again, you see there's a hole that we made. It's all here. I can go ahead and push to bring all of this information in. And once it's done, all the models are here and ready to go. Okay. Now, this PCB, like I said, is associative. So if we make a change in the original sketch, it will flow to here, and then from here, it will flow to the 2D PCB. So let's look at that entire workflow so you can see the biggest advantage of this. And it's the fact that the three files are kept linked together. So let's go back to our model. And I'm just going to go ahead and edit sketch again. I'm going to add another hole. Let's just add another hole. Make the simple change, make it obvious. I'm going to say, okay, I've added it. Finish the sketch. We save. I'll say added another hole. Say okay. Now we go here to the associative. It detects it. We go ahead and bring it in. Again, you don't see anything change because the sketch has changed, but I haven't updated the edit board. Right click here, edit board. And now I can just take off this bit right here. There we are. Say okay. So we made the change. Now we push it to the 2D PCB. And there we are. And again, I can push it back to make sure it has all the changes. And now we're going to go ahead and save. Did the full workflow from enclosure to 2D PCB associative. Okay. And there we are. We can see the 3D PCB is linked again. So at this point, we've covered options 2 and 3, which as you saw are very similar. They only differ in one step. And that is the option 2. If we go over here to the enclosure, create PCB, you either create an associative or an independent PCB. If you do independent, that was option 2. If you do associative, that's option 3. Independent PCB has the advantage that it can be inserted back into the original model with no penalty. Downside is it's just a snapshot of the sketch. It won't have any updates that you make to the sketch afterwards. The associative PCB has the advantage that it will track the sketch and any changes that happen to it. The downside is that you can't directly insert it back into the original 3D model. Rather, to work around it, you have to create a separate file and insert the 3D PCB as well as the enclosure as external assemblies. And this way you indirectly work around the circular reference issue. So this covers options 2 and 3. Now what we're going to do is we're going to look at option number 4. Option number 4 is the most recent, and it is the edit and place workflow. Now let's talk about option 4, the edit and place workflow. This is the most recent of the different ECAD-MCAD workflows, and it's really interesting because it doesn't rely at all on associative or independent PCB, but it has the benefits of both. It does allow you to insert into your enclosure, and it does allow you to keep track of changes to a sketch. So it's a really interesting workflow, and that's the one I'm going to show you now. So this one actually starts at the 2D PCB. So what I'm going to do is I'm going to go ahead and first close these PCBs. We won't need them for now. Close that one. I'll close the combined file. We won't need that one either. Now let's go over here to the 2D PCB. Now the first thing I want to do is break the link to the associative 3D PCB. So I'm going to go ahead and break it. Just go ahead and close it. We don't need this for now. Save it, it's fine. I'll leave it user save for now. Okay, so we've broken the link. Next, I'm going to go ahead and delete the existing outline because it's going to look very much like what we're going to use, so it won't be easy to tell if something changed. So I selected it all, hit delete. You'll notice now it's all black. So we don't have that color difference, which means we don't have a valid board shape. So what we're going to do is going to just draw any old board shape. I'm going to go ahead and use the line command. Just draw a board shape. Just something so that it'll be easy to tell. Okay. Perfect. And you can see we did it right because we got the color change. So I'm going to say OK. Now we're going to go ahead and create a new 3D PCB from the 2D PCB. So already you're noticing a difference. The edit and place workflow starts at the 2D PCB and not at the enclosure. I'm going to say switch to 3D PCB, just create it. Okay, we've created it. At this point, I'm going to go ahead and save it. We're going to call it the EIP, Edit in Place Workflow PCB. Okay, I'm going to save it. Now you'll be able to see that everything else updated. If we go to the electronics design file, we see that it's already been linked. Everything is linked and saved. So now let's go ahead and go back to the enclosure. And the first thing we're going to do now is we're going to go ahead and insert our edit in place workflow PCB. So right click, insert into current design. Okay, we're going to need to rotate it. Let's make sure that's all correct. Okay, let's do it right here. Shift. 90 degrees. Okay, this one. Go 90 degrees again. And now we're going to do a point to point. Select that point, take it over here. There we are. Let me make sure everything is aligned. It is perfect. I'm going to say OK. All right, so now we have our inserted PCB kind of in the right place. Now, how do we get its outline to update? You notice if I hover over this component, we get a little pencil. This is the edit in place pencil. So I'm going to go ahead and click it. It's going to activate edit in place context. All right. And the first thing we're going to do is we're going to go over here to the sketches. Now this is the outline sketch that is part of the PCB itself. I'm going to turn it on and we're going to edit it. Edit sketch. So So what we're going to do is we're going to take out everything that's already here. We're just going to empty out the sketch. Okay. We do that, hit delete, it's gone. Okay. We're going to say finish sketch. Now when we do this, you're going to see that the PCB itself now updates because we eliminated its outline sketch. It doesn't have a sketch anymore. So we're going to right click and say edit board. And now we pick a profile. We're going to use this one that we have already sketched into the enclosure. This is our pre-existing sketch, so we're going to use a select it. You see the origin is in the wrong spot again, so we'll go ahead and place it in the right spot. Select our x-axis and flip it so that it points the right way. I'm going to say OK. And we can see, and now the board has updated. I'm going to say finish edit in place. Okay. So what we're going to do, let's make sure we see it all visible. Looks nice. We're going to go ahead and save the design. Now notice that when I hit save, it says it's saving two designs, right? We're saving our enclosure and we're saving the edit and workflow PCB because that one's changed as well. I'm going to say updated EIP PCB. Hit OK. Now if we go to the 3D PCB file, we see it's changed. We can bring it in. We see it came in. Now we push it to the 2D PCB. 2D PCB is updated. And now we can push back to the 3D PCB to make sure just everything is up to date on the 3D PCB as well. Okay, so now everything is up to date. So you can see that any changes that we make now in the sketch that is in this enclosure, if we modify the sketch, we can now pull that using edit in place, pull that into the 3D PCB, come back here, and come back to the 2D PCB. So that's how the edit in place workflow behaves. And I would say this is kind of the recommended option moving forward. It has all the benefits of independent PCB because it can be inserted into the original enclosure, but it also has the benefits of associative PCB because it can use the derived, it can use a sketch in the enclosure, and any changes there can be updated using the edit in place workflow. So you get both benefits, right? It's not just a sketch in time, and it can be inserted into the original model. So these are the four options that we wanted to go over for deriving or for creating your PCB outline. The first one, which is the simplest, is just drawing it on the 2D PCB itself. Options 2 through 4 all derive their outline from an enclosure. So you could argue that the next easiest is option 2, which is creating an independent PCB. Snapshot in time, has no link back to the original sketch. But if you do want to be able to track changes and update the PCB outline as you make changes in the enclosure, then options 3 and 4 are your best bet. In the next episode, we're going to dive headfirst into the PCB layout. So don't miss it. Thank you very much for taking this time with us, and we look forward to seeing you on the next one. Thank you very much, and bye.